Well, some people say, now wait a minute, a black hole is an object so dense that even light itself cannot escape. So how can sound escape when even light itself cannot escape?
In the vast expanse of the universe, where the boundaries of reality blur and the unknown signals, NASA, the vanguard of space exploration, has made a discovery so astonishing that even the most seasoned astrophysicists are left dumbfounded. Deep within the heart of a black hole, where gravity devours everything in its voracious embrace, lies a secret so chilling that it challenges the very essence of our understanding of the cosmos. What secrets lie within the enigmatic depths of a black hole? Could it be a gateway to another dimension? A cosmic portal that challenges the very limits of our understanding? Join us on this journey as we unravel the terrifying truth that NASA has uncovered inside a black hole. Black holes are like the ultimate suction machines in space. Black holes come to life when the leftover cores of dead stars crash into each other. If their combined mass is over 3 times that of the Sun, gravity takes charge, making the remnants collapse and form a black hole. These black holes are super dense, packing so much mass that their gravity is crazy strong, trapping even light. Most galaxies, whether spiral or elliptical, have these mysterious entities. It's like a cosmic trap. Anything that gets too close gets pulled in and disappears. It might sound like a crazy idea from a sci-fi movie, but scientists have been studying these mysterious black holes for a long time, and they've figured out what's going on inside them. When really big stars finish their life journey, they run out of fuel, just like a car running out of gas. These stars keep themselves together through a balance between the pressure pushing out from nuclear reactions in their cores and the gravity pulling everything inward. But when the fuel runs out, it's game over. The balance collapses, especially for smaller stars like our Sun. This leads to them shedding outer layers, creating a cool thing called a planetary nebula. What's left behind is a small, dense core known as a white dwarf. It's all a connected celestial dance, shedding layers and leaving behind these fascinating remnants in space. Scientists have been studying these mysterious spots called black holes for ages, and they've uncovered some mind-blowing stuff. When super big stars, at least 8 times heftier than our Sun, reach the end of their lives, things get wild. Smaller stars, like our Sun, gracefully shed their outer layers, leaving behind a cute core called a white dwarf. Gravity takes over, and the core collapses even more, becoming super dense. If this core's mass hits a specific limit, about 3 times the mass of the Sun, a crazy gravitational force kicks in. It's so strong that not even light can make a run for it. This critical point is called the Schwarzschild radius, or the event horizon. The collapse creates a super-dense center, a singularity, where the laws of physics throw in the towel. Around this, there's the event horizon, marking the edge of the black hole's territory. Once anything crosses this boundary, it's like being caught in an eternal cosmic tug-of-war. The event horizon is like a cosmic point of no return. If we get too close, there's a specific line called the event horizon. Once we cross that line, there's no turning back. This event horizon is where the gravitational pull of the black hole is so crazy strong that not even light, the fastest thing we know, can escape. Once something crosses this invisible line, it's on a one-way trip toward the black hole's core, called the singularity. This is like the black hole's super-dense heart. As things get closer to this heart, the gravitational force gets stronger. It's like cosmic taffy. Things get stretched and pulled until they're torn apart, a process scientists amusingly call spaghettification. Once it passes the event horizon, it is spaghetti-bound to the singularity. Everything gets stretched and pulled until it's basically gone. Not all black holes are the same. They come in different sizes and personalities, making each one a bit of a cosmic character. First, there are stellar black holes, which are the most common ones. They happen when big stars run out of fuel and go boom in a supernova. The leftover core collapses, and if it's heavier than about 3 times the Sun's weight, it becomes a stellar black hole. These black holes can weigh from just a few times to a whole bunch more than the Sun. Then, there are the supermassive black holes. They chill in the centers of most galaxies, including our Milky Way. They're way bigger than stellar black holes, with masses that can be millions to billions of times the sun's weight. Scientists are still figuring out how these giants form, but the guess is they might get bigger by munching on stuff, merging with other black holes, or maybe both. Intermediate black holes are a bit like cosmic enigmas. People think they exist, but actually spotting them is a bit of a challenge. There's a middle ground for black holes, sandwiched between the smaller stellar ones and the huge supermassive ones at the center of galaxies. These middle-of-the-road black holes are called intermediate black holes. Scientists think they weigh thousands to tens of thousands of times more than our sun. They're bigger than most stellar black holes, but smaller than the supermassive ones. How do these intermediate black holes come to be? Scientists are still figuring that out. One idea is that they might form when smaller black holes join forces, or when a bunch of matter gathers in crowded stellar neighborhoods. Another thought is that they could be leftovers from massive stars hanging out in places where stellar crashes or other space events happened. The gravastar is like an attempt to fix the weirdness of black holes, but without relying on fancy, untested ideas about quantum gravity. The name might sound a bit random, but that's just how astronomy terms go sometimes. A black hole has this super dense point called a singularity at its core, but a gravastar is different. Instead of a singularity, it's filled with dark energy. Dark energy is this mysterious stuff that's everywhere in space and makes the universe expand. It might sound like sci-fi, but it's real. When stuff falls onto a gravastar, it can't go past the event horizon because of all the dark energy inside. So it just hangs out on the surface. Gravastars act and look a lot like regular black holes, but with this twist involving dark energy. It's like they're the cosmic siblings of black holes, playing by similar rules but with their own unique style. Gravitational wave detectors recently caught the cosmic drama of black holes merging, and this might put a damper on the idea of gravastars. Gravastars, which are filled with dark energy instead of a singularity, could have given off a different signal during a merger compared to black holes. LIGO and Virgo, the cosmic detectives, keep finding new cases, and it seems like gravastars are facing tough questions. However, scientists are also exploring a more down-to-earth explanation for singularities in black holes. Instead of imagining a dull point of infinite density, real black holes with some spin create more interesting scenarios. When they spin, the singularity transforms into a ring, and according to Einstein, we might even pass through a wormhole and pop out on the other side in a brand new part of the universe. One challenge we face is that the insides of spinning black holes are really wobbly. This comes from the same idea that suggests traveling to a different universe is possible. The hitch with spinning black holes is, well, they spin really fast. The singularity, which is like the center point all crammed with infinite stuff, gets stretched into a ring, and this ring spins so crazily fast that it creates a huge force pushing things away. In simple terms, it forms an inner zone within the black hole. This inner zone is like a tipping point. Stuff is falling into the black hole, pulled by its super strong gravity, but near the spinning ring, the anti-gravity effect kicks in. Imagine coming across this inner zone, the entire history of the universe hitting us in the face faster than a blink. According to our calculations, this should make black holes disappear. But we've seen spinning black holes in the real universe, so there's some mystery in our math. Luckily, thanks to a cool idea called gravitational waves, we've got a sneak peek into what's happening inside black holes. The recent work might help us figure out what happens when black holes crash into each other, which is the most intense thing ever in the universe. Back in 2015, scientists detected gravitational waves for the first time. They used really big and accurate tools to see the wiggles in space when black holes collide, creating chaos that echoes everywhere. Since then, scientists have found almost 100 new black holes through these gravitational waves spreading across the universe. It's kind of like shaking a box and trying to guess what's inside by listening to the sound it makes. Here, The shaking is when two black holes smash into each other, and the sound is the gravitational waves they send out. The measurements from this process were used in the new study to make better models of cosmic events. Scientists hope this will help them understand what's happening inside and check if Einstein's ideas about gravity still hold up in these extreme situations. Until recently, scientific models mostly focused on straight-line interactions, which worked fine but had some limits. With this new research on more complex interactions, models could get up to 10% better. This research will also help scientists spot more crashing black holes down the road. It's a big step toward getting ready for the next round of gravitational wave detection that will dig deeper into our understanding of gravity and these incredible happenings in the far corners of the cosmos. Thanks to the pandemic, LIGO, the observatory that first spotted gravitational waves, has been offline since 2020. A recent study from the University of Michigan has added more intrigue to these deep space wonders. The researchers suggest that black holes might be like holograms. They're not saying black holes are sci-fi projections like in the movies. Instead, they're using holograms to explore how the inside of a black hole connects to the outside. Enrico Rinaldi is leading this research based on the idea of holographic duality, which says that theories about gravity and particles are mathematically the same. The idea of black holes is like trying to solve a space puzzle, small ones, and those in between. Scientists are still figuring out how these in-between ones, called intermediate black holes, come to be. Bigger than regular black holes, but not as gigantic as the ones in the center of galaxies. Catching these intermediate black holes is like searching for a needle in a haystack. They don't always show off flashy signs like their smaller or larger counterparts. Scientists think they might form by teaming up smaller black holes or gathering matter in crowded star neighborhoods. Another theory is that they could be leftovers from massive stars that had a rough collision. These intermediate black holes play a mysterious role. We've got some clues, but there's still a lot to unravel. Every day, space enthusiasts and astronomers take steps to understand this cosmic puzzle. Imagine a hologram as a kind of magic picture. It's a flat image that tricks our eyes into seeing a 3D object. Think of it like a holographic two-pack, a 3D image of a two-pack projected onto a flat surface. Scientists are doing something similar with black holes. They're describing a black hole with a 3D center, but what we actually see is a projection in 2D. It's like looking at a 3D object on a 2D screen. They use quantum matrix models to study how gravity and particles are connected. Right now, we can only describe the inside of a black hole using math. We won't really know what's going on inside until we can observe it in a way that challenges what we currently understand about the universe. It's a bit like looking at a hologram. Recently, astronomers stumbled upon a previously unknown black hole that made its grand entrance by tearing apart and feasting on a star that ventured too close. This cosmic drama unfolded in a dwarf galaxy a million light-years away. The event, known as a tidal disruption event, caught astronomers' attention when it unleashed a powerful burst of radiation, briefly outshining every star in its cozy dwarf galaxy neighborhood. This TDE is like a cosmic spotlight, helping scientists study the connection between galaxies and the black holes living within them. It also provides astronomers with another intermediate black hole to explore. This discovery has stirred up quite a buzz because it not only allows scientists to find more mid-sized black holes in peaceful dwarf galaxies, but also lets them measure the masses of these cosmic consumers. The TDE flare, known as AT2020NEH, was found by astronomers using the Young Supernova Experiment, a survey that spots short-lived celestial events like supernova explosions. As the black hole started gobbling up the star, catching this initial moment of destruction was crucial. An international team led by UCSC scientists and Niels Bohr Institute astronomer Charlotte Angus used this observation to measure the black hole's mass, which turned out to be between 100,000 and 1 million times the mass of our Sun. TDEs have been used before to measure massive supermassive black holes, but this is the first time they've shown they can also document the masses of smaller mid-sized intermediate mass black holes. So, the initial sighting of the speedy AT2020 NEH flare could be a starting point for future measurements of mid-sized black hole masses. They caught a glimpse of what would have been hidden from us, capturing this mid-sized black hole munching on a star. Plus, we can use the properties of the flare to gain better insights. This mysterious group of middleweight black holes, which might make up most of the black holes in galaxy centers, has intrigued physicists for a while. They suspect that supermassive black holes, with masses ranging from millions to billions of times that of the Sun, could come to be by merging intermediate mass black holes. In the early universe, there were many dwarf galaxies with intermediate black holes. As these dwarf galaxies merged or were swallowed by larger ones, their intermediate black holes devoured each other, growing in mass. This domino effect of ever larger mergers could eventually lead to the formation of supermassive black hole titans at the centers of most galaxies. Detecting these intermediate black holes isn't easy. Unlike stellar or supermassive ones, they don't always show off the same noticeable features. Even though it's a tough task to directly see them, smart scientists have ways to guess their existence. Watching how stars move in certain areas or checking out the gravity in star clusters could drop hints about an intermediate black hole hanging around. But whether it's a small, medium, or super huge black hole, one thing's for sure: inside is a wild mess of pure chaos. The tricky part is, we can't get anywhere close to these cosmic enigmas yet. Every day, though, we're unlocking more secrets about them. Astronomers recently hit the jackpot using NASA's Chandra X-ray Observatory and the James Webb Space Telescope. They stumbled upon the most distant black hole ever spotted in X-rays, just 470 million years after the Big Bang. It gives us a sneak peek into the early days of the universe when everything was just starting out. What's really cool is that this black hole is still in its growing up phase, something we've never seen before. It's hanging out with its host galaxy, and they kind of grew up together, which is pretty neat. Figuring out how these supermassive black holes, which can be millions or even billions of times heavier than our Sun, came to be in the early universe has been a big puzzle. But with this discovery, scientists got some key hints. They used the Chandra X-ray Observatory to catch those X-ray signals that black holes send out, helping us learn more about these mysterious cosmic entities. Astronomers used not one but two super-powered space telescopes, the James Webb Space Telescope and the Chandra X-ray Observatory, to crack this mystery. JWST found a far-off galaxy called UZ1, and Chandra spotted a supermassive black hole hanging out in there. But it wasn't a walk in the cosmic park to figure it out. Gravitational lensing, a fancy term from Einstein's genius brain, acted like a magnifying glass. There's this massive blob of matter in a galaxy cluster called Able 2744, chilling between us and Z1. It caused a lensing effect, making the light from the galaxy and the X-rays from the black hole look way bigger and brighter than they actually are. At first, scientists thought it was just a part of the Able 2744 gang, but turns out it's a superstar on its own, our distant black hole pal. The galaxy Z1 turned out to be way out there, like 13.2 billion light-years away from us. That means it's from a time when the universe was just a tiny 3% of its current age, making it one of the farthest galaxies we know about. Chandra, the space detective telescope, caught some serious action. It saw super bright X-ray flashes coming from the super-hot gas hanging around the supermassive black hole in UZ1. This is a big deal because it's the first time we've seen a growing black hole doing its thing so early in the universe's life. The study suggests that this new black hole was born a heavyweight, with an estimated mass between 10 and 100 million times that of our Sun. What's interesting is that it's kind of like a cosmic twin, with the stars in its host galaxy, breaking the usual pattern where black holes are usually much lighter than the stars they chill within nearby galaxies. The scientists found that when black holes start out bigger, they have a head start in growing. If a black hole begins with more mass, it can grow faster than one that starts smaller. This matches the similar masses we see between the black hole and the stars in its galaxy.